So in this lesson, we're going to learn how to determine if the equation of two lines, whether their graphs are parallel, perpendicular, or neither. Now, before we can understand this concept, we need to understand what we mean by two graphs being parallel. Now, these two graphs are parallel, and I drew it in such a way that if you extend the lines in infinite directions, like they are here, they will never intersect. So you learned in a previous course that two lines are parallel, in a geometry course, that two lines are parallel if they don't intersect. All right. But in particular, though, I want to look at this in terms of the slope. Let's look at the slope of this line, and let's look at the slope of this line. We know that these lines are parallel, right? So these lines are parallel by the way I drew it. So these lines are parallel. Okay, so those lines are parallel. I want to look at the slope, though. So let's look at the slope of that first line. So I'm going to call this line L1. L1. So the slope of L1 equals. Now remember, one of the ways that we talked about slope was rise over run. So let's look at it in that aspect. So the slope is rise divided by run. So the rise, remember, is the change in y divided by the change in x. Now you could use the slope formula here, but it is quicker just to use the idea of rise over run since the graph is given. Okay, so here are 2 points in this graph that, denoted by the 2 dots here. And so I'm going to use this point here. So from this point to get to this point, I'm going to rise, and so I'm going like this: 1, 2, 3, 4, 5. So my rise is 5, right? My rise is 5. And my run, I'm going to the left. So remember, when you go to the left, your run is negative. So 1, 2, 3, 4, 5, 6. So your run equals negative 6. So the slope of this line then would equal the rise, which is 5, divided by the run, which is negative 6, or you could say negative 5, 6. So the slope is negative 5, 6. And you knew it had to be negative, right? You knew this line had to be negative because my line is falling. So we learned that in a previous lesson as well. Now let's look at the slope of this line. Let's look at the slope of this line. We're going to do the same thing. So let's start with this point here. So use the same idea. So let's call this line 2. So the slope of line 2 will equal, I'm going to use rise over run. So to get to this point, I'm going to rise. Remember, rise, you go up or down. In this case, I'm going down. So I'm going 1. Let's do this. 1, 2, 3, 4, 5. Okay. So I'm level to this point now. So my rise equals. Now remember, I went down, so I'm going to have to say my rise is a negative 5. And my run, 1, 2, 3, 4, 5, 6. Since I went to the right, my run is a positive. So my run is 6. So my rise is negative 5, my run is 6. So I get negative 5 divided by 6. So the slope of line 2 is negative 5, 6. So what do you notice about these two slopes? So the slopes are the same, right? So and we knew those lines are parallel because of the way I drew it, they would never intersect. So the lines are parallel. So we know this now. We know that parallel lines have the same slope. So I'm going to write this right here. Parallel lines have same slope. Okay? All right, so that's important. Parallel lines have the same slope. Okay, now let's look at these two lines. Now, remember that in a geometry course that perpendicular lines intersect at right angles. So we knew this. We knew that perpendicular lines intersect at right angles. Okay, so we learned that in a geometry course. Okay, so I drew these two lines so that they were perpendicular. And I know they're going to be perpendicular, and let's use this as an aid. So these two edges right here that you see, I'll make it clear right here. So those two edges right here, they form a right angle, right? So this is a right angle right here. So I'm going to just put that right here. So that's a right angle. So if I take that little corner, if I take that corner and put it here, you'll notice that when I put the edges over those two lines here, those two lines, notice that those two lines will form a right angle. See that? All right. So those two lines, by the way I drew them, are perpendicular. All right, now let's look at the slope. I'm going to use the same idea that I did here. I'm going to use rise over run. Okay, so on this line, let's call this line 1. All right, and so the slope of line 1 equals, all right, slope of line 1 equals, all right, so these are my 2 points that I know on this line. So I'm going to use the idea of rise over run. So I'm going to go here. So my run, this run right here, is 1, right? So let me write this as rise over run. So my run here is 1. I went to the right, so it's positive 1, so that's going to go to the denominator. And my rise, when I go up, 1, 2, 3. So my rise is 3. So the slope of this line is 3, right? And we knew it had to be positive because the line is rising. But that's the slope of that line. And if you use a slope formula, if you denoted those coordinates of the 2 points and use the slope formula, we get 3 as well. All right, now let's look at the line here. Now we know that this slope better be negative, correct? That slope better be negative because the line is falling. All right, so here are 2 points, 1, 2. All right, let's start here. I'm going to go down, so that's going to be my rise. So I'm going to go down, though, since I'm going down, it's be negative. 1, 2, so I went down 2, right? All right, so I'm going to put that here. So let's call this line 2. So the slope of line 2 equals, all right, so I went down 2. So that's my rise. So I'm going to rise over run. So my rise is negative 2, right? I went down, so my rise is negative 2. Divided by my run, I'm going to the right, so my run is going to be positive. So 1, 2, 3, 4, 5, 6. So that's 6. All right? So when I reduce this, that's going to be a negative 1/3. Okay? All right, now here's what's important. If I ask you this question, if I ask you, what is the reciprocal of 3? Well, the reciprocal of 3 is 1/3, right? Okay? And if I cover that negative, you see that 1/3 here. What if I ask you, what is the opposite reciprocal of 3? So remember, you take the opposite. Since 3 is positive, the opposite is going to be negative 3, right? So the opposite of 3 is a negative 3. But when I say you take the opposite reciprocal, then that means if this is positive, this would be negative, and then you would take the reciprocal of 3, which is 1/3. Okay? So here's another way of saying that. Okay, so look. So if I ask, what is the opposite reciprocal of, let's say, 2/3, then the answer is, so you're going to take the reciprocal. So the reciprocal is 3/2. The reciprocal of 2/3 is 3/2. And then you take the opposite of that sign. So if this is positive, this is negative. So there's the answer. Okay? What if I ask you, and let's do this as A. So what if I ask you B, what is the opposite reciprocal of B? And let's say B was 7. Okay? So the answer would be, first of all, let's take the reciprocal. The reciprocal of 7 is 1/7. And then you take the opposite of that sign. If this is positive, and this is negative. All right? And then C, suppose we had a negative 1/8, let's say. So the answer, first of all, take the reciprocal of 1/8. The reciprocal of 1/8 is 8 over 1, which is just 8, right? And then since this is negative, you're going to take the opposite of that sign, so it'll be a positive 8. All right, so that's what I mean by taking the opposite reciprocal. I want you to remember, though, that another word of saying opposite reciprocal, another way of saying opposite reciprocal is negative reciprocal. Negative reciprocal. All right, but we're going to use the word opposite reciprocal here. Okay? So what we should notice is this, and this is going to be important. So we know those lines are perpendicular. We know that their slopes are opposite reciprocals of each other. All right? So perpendicular lines, and this is important, that's going to be needed. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so perpendicular lines have slopes that are opposite reciprocals of each other. Now, some textbooks will also say this, so I'm going to go ahead and say it just in case you see it somewhere else. So if you multiply two numbers that are opposite reciprocals of each other, so if you multiply two numbers that are opposite reciprocals of each other, okay, for example, 2/3 and -3/2, so 2/3 times a -3/2. So if you multiply these two numbers, they're opposite reciprocals of each other. I'm going to multiply them. Let me go ahead and rewrite this over. The product, see those reduce out, right? The product, 1 times a -1 is a -1. The product is going to be a -1. So let's look at the other one. 7 and -1, 7. 7 times a -1, 7. When you multiply those, the 7s divide out, you get 1 times a -1, which is a -1. So the other way that some textbooks will say that two lines are perpendicular is this. So you could say this: perpendicular lines, perpendicular lines. Well, let me write it this way. I'm sorry. So two lines are perpendicular. Two lines are perpendicular. Perpendicular. If the product of their slopes, is, and so two lines are perpendicular. So remember, two lines are perpendicular if their slopes are opposite reciprocals of each other, and so their product is -1, right? Okay, so two lines are perpendicular if the product of their slopes is -1. Okay, so parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other. Another way of saying that is that two lines are perpendicular if the product of their slopes is -1. All right, so now we're ready to do some problems. Okay, so let's look at number 1. So here's number 1. All right, number 1. All right, so given the following equation of a line, so here's the equation of this line. And you don't have to graph it. In fact, don't graph it. You don't want to do that. You just want to, in this case, determine the slope, right? And determine the slope of a line that's parallel to it and then a line that's perpendicular to it. All right? So we have this line, all right? And we want to know that if a line is parallel to this, what would be the slope of that line? All right, well, remember, parallel lines, let me get to it. Parallel lines have the same slope, right? All right, so the answer here, first of all, the slope of this line is 4/5. Now, don't say 4/5 x. Remember, it's a coefficient of x. So remember, y equals mx plus b, So remember, this is in slope-intercept form. So whenever you have y by itself, remember that's slope-intercept form. So the coefficient of x is your slope. The y-intercept's not needed at all in here. The y-intercept is not needed at all. You don't need to know what that y-intercept is. All you need to know is what is that slope. That's all you need to know. So the slope of this line is 4/5. So the slope of a line parallel to it is also going to be 4/5. All right? Now, What about the slope of a line that's perpendicular to this? Well, if the slope is 4/5, then the slope of the line perpendicular to it, all you do is just take the opposite reciprocal. So what's the reciprocal of 4/5? The reciprocal of 4/5, I'm going to put answer, slope equals. The reciprocal of 4/5 is 5/4, right? And then you take the opposite of that sign. So if this is positive, then this has to be negative. And if you multiply those two together, 4/5 times negative 5/4, you get a -1. The product is going to be -1. All right, and that's all you do. All right, so over here, number 2, this is already in slope-intercept form, right? So that's already in slope-intercept form. So the slope of this line, what's the slope of this line right here? So the slope of this line is a coefficient of x. So what's the slope of this line? -7/6. All right, so that means that every line parallel to this is also going to be what? -7/6, because parallel lines have the same slope. So the answer, slope will be -7/6. Then if the slope of this line is -7/6, then every line perpendicular to this will have what slope? All right, so the answer, slope equals, and all you do is just take the reciprocal of 7/6. The reciprocal of 7/6 is 6/7, but don't forget, you got to do the opposite reciprocal. So if this is negative, then this has to be positive. So the answer is 6/7. All right, and the answer for this one was -7/6. All right, so that's number 2. Okay, very simple, right? Not difficult at all. Now, number 3. So again, given the following equation of a line, so there's my equation, determine the slope of any line parallel to it or any line perpendicular to it. All right, so first of all, notice this is already in slope-intercept form. So since this is in slope-intercept form, we know right away what the slope is. What's the slope of this line? Slope of this line is 3. All right, slope of this line is 3. All right, so that means that any line parallel to this will also have what slope? Slope 3. Parallel lines have the same slope. So the answer, M, will be 3. Any line perpendicular to this will have what slope? All right, well, answer, slope equals. First of all, we take the reciprocal of 3. What's the reciprocal of 3? The reciprocal of 3 is 1/3. Then we take the opposite sign. So this is positive, and this has to be negative. And there's your answer. So any line perpendicular to this one will have slope -1/3. And if you multiply those two slopes that are that have opposite reciprocals, their product is going to be -1. 3 times a -1/3 is a -1. Number 4. Now, number 4, you're given this line right here, right? Okay, and you want to determine if you have lines parallel to this one, what would be the slope of those parallel lines? If you have a perpendicular line, if you have a line perpendicular to this, what's the slope of that perpendicular line? All right, well, what do you notice about this one compared to the others? Well, in the first 3, you notice that it was already in slope-intercept form. Y was already by itself. Here, it is not. Y is not by itself, so this is not slope-intercept form. So the first thing you have to do, I'm going to go ahead and rewrite this over. First thing you have to do is put this in slope-intercept form, and that's easy because the coefficient of y here is 1, so you just subtract 2x from both sides. And so I get y equals -2x plus 5, right? So the slope of this line right here, so the slope of this line is what? What's the slope of this line? Slope of this line is -2. All right, so a line parallel to this line right here, parallel to this line, either this one or this one, does not matter, will have the same slope. So the answer then will be slope equals -2. All right, but keep in mind, you got to first of all put this in slope-intercept form. All right, now perpendicular, so the answer, slope equals. So if this line has slope -2, then a line perpendicular to it will have the opposite reciprocal. So first of all, the reciprocal of 2 is 1/2. If this is negative, the opposite of a negative is a positive, so there's your answer. All right, so that's number 4. Very simple, not difficult at all. All right, let's look at number 5. All right, number 5. So given the following equation of a line, and so here's our line, you want to find the slope of a line that is parallel to this and the slope of the line that's perpendicular to this. Well, first of all, notice you got to find the slope of this line. Well, it's not in slope-intercept form, so you got a little bit more work to do. So let's go ahead and do this work right here. So I'm going to do this work right here. So I'm going to go ahead and rewrite this over. And so we got to get y by itself. We got to put this in slope-intercept form. Slope-intercept form. So y equals mx plus b. So notice in all the problems, we did not use the y-intercept at all. All we needed was that slope. All right. So there are two ways you could do this. You could bring the 4y to the other side, or bring the, and that's a 3x, or bring the 3x to the other side. It does not matter. Most students will probably leave the variable term that has y in it on this side. So we're just going ahead and do that. You just got to be careful, because at some point you are going to divide by a negative 4. So you got to be careful. All right, so let's go and do that. So let me go and rewrite this over, just like this. I'm subtract 3x from both sides. All right, and so when I do that, I get, when I combine like terms, I get negative 4y. Be careful, that's negative 4y equals the negative 3x plus 6. Now to get y by itself, we're going to divide both sides by negative 4, just like this. Negative 4 divided by negative 4 is 1. 1 times y is y. And then what we're going to do here is going to rewrite this as two separate fractions. Now, write what you see. I see a negative 3x divided by negative 4. Write it out, just like this. Plus, I see a positive 6 divided by negative 4, right? Now, let's simplify this. Y equals, and first of all, a negative divided by negative is a positive. You need to know that, and you need to use that fact. So that's a 3/4 x. And then over here, a positive 6 divided by negative 4 reduced is a negative 3/2. All right. So what is the slope of this line? The slope of this line is going to be 3/4. So the slope is 3/4. So that's what you have to do first. So there was some work you had to do here compared to the others. The others, the work was very simple. Either it was already in slope-intercept form, or it was pretty easy to get it in slope-intercept form. All right. So it's pretty easy to get it to this. Here, though, you had a little bit more work, and you got to be careful with your operations and your properties that you're using. All right. So we know the slope here. The slope is 3/4. So now let's answer the question. So a line parallel to this will have the same slope. So the answer for this one, you're going to say the slope is also going to be 3/4. So the slope is 3/4. Over here, the line perpendicular to this, well, if the slope of this line is 3/4, then the slope of the line perpendicular to this will be, so the answer, slope will equal. First of all, let's take the reciprocal. The reciprocal of 3/4 is 4/3. Then we're going to do the opposite. So if this is positive, then this has to be negative. And there's your answer. All right, so that's number 5. Okay. Now, the other type of question that you're going to ask with relation to this concept is this. Now, here are the directions. For each set of equations, determine if the lines are parallel, perpendicular, or neither. All right. So when we talked here about these lines, when you draw two lines in a plane, they're either going to be parallel, all right, or they may be perpendicular, or they may intersect. Now these two lines intersect, but they intersect at right angles, right? Or they may intersect just like this, these two lines, but they do not form right angles. So these are not perpendicular angles. All right. So the slopes here would not be. So the slope in this case. So the slopes are not the same. Obviously, because they're not parallel, nor are they uh, negative or opposite reciprocals of each other. Reciprocals of each other because they don't intersect at right angles. All right, so then we would say just neither. So that's why you see the word neither there. I just wanted to bring that up. Make sure you understand that when you draw two lines, they're either going to be parallel, they either will not intersect or they will intersect. If they don't intersect, they're parallel. If they do intersect, they're either going to intersect at right angles or they will not intersect at right angles. If they intersect at right angles, they're perpendicular lines. If they don't intersect at right angles, that means that their slopes are not the same and they're not opposite reciprocals of each other. So these lines are neither parallel nor perpendicular. So that's why you see neither here. All right, so first thing we got to do is, if I want to determine if these two lines here are parallel, perpendicular, or neither, all I need to know is the slope. That's all I need to know. All right, so let's call this, and sometimes you'll see this, just to let you know, sometimes you'll see line 1 equals, line 1 is this one, and then line 2 is, those are colons right here. Line 2 is this one. All right, so the slope of line 1 equals, what's the slope of line 1? Y is already by itself, so these are already in slope-intercept form, so that's the easy kind. So what's the slope of line 1? Slope of line 1 is 7. What's the slope of line 2? Slope of line 2 is also 7. So since their slopes are the same, those two lines are parallel. All right, so the two lines, so since the slopes of both lines are equal, that means that the two lines are parallel. The two lines are parallel. Okay, that's all that is. Now this was easy because both lines were already in slope-intercept form, so you could easily determine the slope. All right, now let's look at number 2. Number 2, same thing. So let's call this L1. That's the first line, and this will be called L2, second line. And when I say L1, L2, I really mean L sub 1. These are subscripts right here. 1 and 2 are subscripts. All right, so the slope of L1 is what? They're both in slope-intercept form, so that's easy kind. Slope is 2/3. Don't say 2/3 x. Remember, the slope is just that number you're multiplying the variable by. You're multiplying x by. And the slope here, slope of line 2, is going to be -3/2, right? All right, so first of all, I'm going to ask you, are these lines parallel? No, they're not parallel. For one thing, the slopes are not the same. Are they perpendicular to each other? Are these two lines perpendicular to each other? Well, look at the slopes. This is 2/3. This is -3/2. So the negative or the opposite reciprocal of 2/3 is -3/2. So those lines are going to be perpendicular. All right. So here's the reason though. So the two lines are perpendicular. And by the way, just to let you know, the symbol for perpendicular is, remember that upside down T that you may recall? It looks like this, the symbol for perpendicular. So the two lines are perpendicular since their slopes are opposite reciprocals of each other. All right? Or you could have said this, or you could have said the two lines are perpendicular since the product of their slopes is, and remember when you multiply two numbers that are opposite of each other, what's 2/3 times a -3/2? It's going to be a -1. All right. So either one of those would be the correct explanation. All right. So number 2, the two lines here are perpendicular. All right, let's look at number 3. So in number 3, we have this. All right, so here's number 3. So let's call this line 1 and this line 2. What do you notice about one of those equations? One of those, the equation of the lines, in particular line 2. So first of all, you notice that line 2 is not in slope-intercept form, right? So, but it's easy to get in slope-intercept form. So let's go ahead and do that work here. So for line 2, we have x plus y equal 2. So if I subtract x from both sides, and be careful that you're subtracting x, I get y equals negative x plus 2, right? Okay, so we know this. We know the slope of line 1 is what? What's the slope of line 1? It's already in slope-intercept form. That implied coefficient here is understood to be a 1. So the slope of line 1 is 1. The slope of line 2 equals what? Negative 1, right? Okay, now listen carefully. First of all, you know that those lines are not parallel because the slopes are not the same. They're not equal to each other. But are those lines perpendicular to each other? And the answer is yes, because what is a reciprocal of 1? Well, the reciprocal of 1 is still 1. And then if I take the opposite of that sign, a positive, this should be a negative, right? Okay, so those lines are perpendicular. And in fact, if you multiply those, what's 1 times a negative 1? It's a negative 1. All right, so the two lines are perpendicular, since, and I'm going to use the I'm going to write it this way. The two lines are perpendicular since the product of the slopes is negative 1. 1 times a negative 1 is equal to a negative 1. Okay? All right. So that's number 3. Okay, number 4. Number 4, we have these two lines. So let's call this line 1 right here, this one, and this will be line 2. All right. And so line 1 is already in slope-intercept form. So the slope of line 1 is 8/5, right? The coefficient of x. All right, let's find the slope of line 2. So let's do the work here. So for line 2, we have 8y plus 5x minus 2 equals 0. So I have to get y by itself. I got to get this in slope-intercept form. So first of all, let's bring those two terms to the other side. I'm hoping you see that when I do that, I get 8y equals, when I bring the 5x term to the other side, the sign changes. So I get negative 5x, and then negative 2 becomes a positive 2. So that's what I get. So you're basically adding 2 to both sides. So that's how I get the plus 2, and you're subtracting 5x from both sides. So that's how I get the negative 5x. And then finally, we're going to divide both sides by 8, just like this. And so I get y equals, and let's write this as two fractions. I get negative 5x divided by 8, so a negative 5/8x, and then plus 2/8, right? And then that's an 8. And then reduce, you get y equals negative 5/8x plus 1/4. All right. So what's the slope of line 2? Well, the slope of line 2 is a negative 5/8. So the slope of line 2 is a negative 5/8, right? Okay, negative 5/8. And so now I'm going to write this right here. Slope of line 2 equals negative 5/8. All right, so those lines parallel? No, they're not parallel because their slopes are not the same. But what do you notice about their slopes? Their slopes are negative reciprocals of each other, or opposite reciprocals of each other. So what can you tell me about those two lines? The two lines are perpendicular. So the two lines are perpendicular since their slopes are opposite reciprocals of each other. Opposite reciprocals of each other. Okay? All right. And you could have also said, since the product of their slopes is negative 1. 8/5 times a negative 5/8 is negative 1. All right, that's number 4 rather. Let's go number 5. So it's very simple, not difficult at all. Now in this case, you have to do both. You have to get for both equations, you have to get this in slope-intercept form. So let's go ahead and denote this as L line 1, and this will be L2. So for line 1, which was this, 3x plus y equals 0, if I get this in slope-intercept form, I get y equals negative 3x, and that's all I have. All right. So the slope here is going to be negative 3. So far I know this. The slope of line 1 equals negative 3. All right. Now, just out of curiosity, there's no constant there, right? So what's the y-intercept? The y-intercept would be 0. Remember, negative 3x means the same thing as, just to remind you, this same thing as, say, negative 3x plus 0. So the y-intercept is 0. But that was not needed here, but I just wanted to see if you remembered that. All right, now we do the same thing for line 2. So for line 2, I have 3x plus 2y equal 3, right? Okay, so to get y by itself, let's go ahead and subtract 3x on both sides. And so I get 2y equal negative 3x plus 3. And then divide both sides by 2. I get y equals, and let's write this as two fractions, negative 3 halves x, and plus 3 halves. All right, so the slope of line 2 then is going to be negative 3 halves. Okay, all right, now, so therefore, are those two lines parallel? Well, they're not parallel because the slopes are not the same, they're not equal. Are the two lines perpendicular? No, because first of all, they have the same sign, right? And so they can't be perpendicular. The signs have to be different. And also, the reciprocal of 3 is 1/3, and that's not 1/3 right there. So it's neither. So these lines are not parallel nor perpendicular. But if you graph them, just to remind you, if you graph them, they will intersect because they have different slopes, but they won't intersect at right angles. All right. So you say this. You say the two lines are neither perpendicular nor parallel. All right. So they're neither. So they're neither because the slopes are not the same and the slopes are not opposite reciprocals. All right, and then finally, let's look at number 6. So same idea. You got both of those are not in slope-intercept form, so you got some work to do. So let's take that first equation. Let's call this line 1 right here, and this will be line 2. All right. So for line 1, which was negative 7x plus 2y equal 1, let's get y by itself. So I'm going to add 7x to both sides. So when I combine like terms, I get 2y equal 7x plus 1. And then I'm going to divide both sides by 2. And so I get y equal 7 halves x, right, plus 1 half. So the slope of line 1 equals, what's the slope of line 1? Slope of line 1 is 7 halves. All right. Now let's do line 2. For line 2, which was this equation, negative 14x plus 4y equal negative 9. Let's see what we get. So I'm going to add 14x to both sides. Okay, and then combine like terms. That's 0. And then 0 plus 4y is 4y equal 14x minus 9. Then divide both sides by 4 to get y by itself. I got y equal, write this as two fractions. I get 14x divided by 4 minus 9 divided by 4, but reduce. 14 fourths reduced is 7 halves. So I get 7 halves minus 9 fourths. So the slope of line 2 is what? 7 halves. So what do you notice about the two slopes? The slope of line 1 and the slope of line 2 are the same. So that means that these two equations, these two lines are going to the equation. The graph of these two lines will be parallel. They have the same slope. So the two lines will be parallel. All right, since the slopes of both lines are the same, are equal. Okay. All right, and that's it. That's the idea with this lesson. So in this lesson, let me go ahead and quickly find that first part. So in this lesson, you had to use the fact that parallel lines have the same slope, and you have to use the fact that perpendicular lines have slopes that are opposite reciprocals or negative reciprocals of each other. And also, we know that two lines are perpendicular if the product of their slopes is -1. And knowing this, then you could answer anything dealing with determining whether the equations of two lines, whether their graphs are going to be parallel, perpendicular, or neither. All right, so that's the end of this lesson.